Let us look at the next section, students. This section contains two paragraphs. Each paragraph has two questions. Each question has four options, out of which one or more than one option may be correct. Let us look at the paragraph given for question number 37 and 38. So we have been given a reaction in which a simple aldehyde is allowed to react with OD minus in presence of D2O, and it is kept there for prolonged time interval. And it is further given to us that the product contains only two carbon atoms. So we have been given that the CH, CO, CC and OH bond energies are X, Y, Z and W respectively. In question number 37, the examiner says that simple aldehydes and ketones do not mainly exist as enols. This is because. So if we talk about the bond energies which are given to us, students, we know that the C double bond O has a greater bond energy than C double bond C. So if we talk about the values, we know that C double bond O is labeled by Y and the C double bond C is labeled by Z. So out of option C and option D, we can see that option C is incorrect while option D is correct. Now if we talk about the CH and the OH bond energies, we know that the OH bond is stronger than the CH bond, which means that OH, which is represented by W, is going to have a greater value than X. So if you look at the B option now, the B option is incorrect, students. X is not more than W, it is W which is more than X. And if you talk about the A option now, which says that X plus Y is greater than Z plus W. So if we talk about the value of X plus Y, which means that we have a CO and a CH and we have a CC and an OH. So it is a fact that the sum of X plus Y is greater than Z plus W, which is the major reason for the stability of the keto forms and not the enol forms. So students, we can see that the option A is also correct. So for question number 37, students, we have to mark the correct answer as option A and option D. Let us look at the next question. Question number 38. Maximum difference between molecular weight of product formed in the above reaction and reactant is. So if we talk about the reaction which is happening, we have three alpha hydrogens in this case, and all of these three alpha hydrogens shall be replaced by D present in the solution via the base catalyzed enolization. So students, the final product is expected to be CD3CHO. So we can clearly see that the difference in the molar mass of the product and the reactant shall be equal to 3. So for this question, we have to select the correct answer as option C. Let us look at the next paragraph given for question number 39 and question number 40. So we have been given a reaction sequence. So A is first allowed to react with SnCl2 and it forms a white precipitate C. The white precipitate C is further allowed to react with excess of SnCl2 and it forms a black colored precipitate. The same compound A, when react with Ki, it gives a scarlet red, and the scarlet red precipitate which is allowed to react with excess of Ki, it becomes soluble. So the soluble compound formed is now allowed to react with NH4OH and it gives us a brown colored precipitate. So it is further mentioned to us that A is a chloride salt and F is iodide of Millen's base. Students, iodide of Millen's base has the formula NH2 HgO HgI, which means that the compound must contain mercury. So students, we know that the compound E has to be the Nessler's reagent, which is K2HgI4. And if we talk about the compound D, it will follow that the compound D is HgI2, which implies that the compound A will be HgCl2. The test for compound A can also be validated by the above sequence of reactions. We know that HgCl2, when it is allowed to react with SnCl2, it forms Hg2Cl2, which is a white precipitate. And when the white precipitate is allowed to react with excess of SnCl2, it forms mercury. It is further reduced and gives us a black colored residue. So we now have all the compounds in the system. If we talk about question number 39, we have to select the correct answer. Option A, it says black PPT G. So the black PPT G was mercury. Also gives a white precipitate with HCl. This is incorrect, students. Mercury does not react with HCl to form Hg2Cl2. Let us look at the next option now. White precipitate C is Hg2Cl2. This is correct, students. If you look at the statement C now, Compound F is called as Nessler's reagent. This is incorrect, students. Compound F is not Nessler's reagent. It is compound E, which is the Nessler's reagent. And if you talk about the D option now, it says that the A does not respond to chromyl chloride test. So compound A was HgCl2, and we know that HgCl2 has significant covalent character and it does not respond to the chromyl chloride test. So for question number 39, students, we have to select the correct answer as option B and option D. Let us look at the next question. The examiner seems to be interested in the color of the product obtained by the reaction of C with NH4OH. So students, we know that the compound C was Hg2Cl2, and when Hg2Cl2 is allowed to react with NH4OH, we know that it undergoes disproportionation to form mercury metal and mercurous amido chloride. So we have HgNH2Cl. So students, we know that the color of this product mixture is black. So if you look at the options which are given to us, we can clearly see that we have to select the correct answer to question number 40 as option D. So this is it for today, guys. I hope the solutions were clear to you. Thank you.